So in this problem, basically, the question says, how would you affect the following conversions? Which means simply you have the starting material out here, you're supposed to make the product, and the question is, how do you go from here to here? So for this one, we'll focus on A, B. We're not going to do C and not going to do, sorry, we're not going to do B, we're not going to do C, but we'll do D and E. And the reason we won't do B and C is because B and C are just, B is extremely long and kind of like you'll probably get really frustrated doing it, and then it's not really going to show up on the test. And then C is actually requires some stereochemical implications, so um, that's not where the focus is going to be. So we're not going to worry about B and C for this video. We'll just do A, D, and E. All right. So let's take a look at A. So in A, I'm going to go ahead and do this on a different page so we can strategize separately. Okay. So A is you are starting with this material and you're trying to make this. Okay. Now, key to remember out here is that you have a double bond out here. Okay. And you have a bromine out here, which means that this piece likely came in with a Grignard reagent, and that double bond should basically tell you that, hey, maybe you can put an OH out here. So let's think about this retrosynthetically. So if I go backwards from that product, I put an OH out there, I get this, okay? And then that means this piece came from the Grignard, which we talked about, which means that thinking one more step back, I could have a cyclohexane out there, and then this piece came from the Grignard. So let's see how we can kind of make that. All right. So the strategy out here is before you can make this a Grignard, you want to protect the OH. So the first step we'll do TMSCl, and that's going to make that an OTMS. Next step, we're going to add magnesium dry ether to make that a Grignard. Then we will react that Grignard with cyclohexanone, okay? And that gives us OTMS, and that's O minus MgBr plus, okay? Okay, and then in one step, we'll do an H3O plus in the next step, and that will actually protonate the O minus and deprotect the OTMS. That gives us OH. And then we just have to dehydrate this OH. So we could go ahead and just do a concentrated H2SO4 out here. And that would dehydrate that OH, giving you the product. All right, let's take a look at the D. So D out here, you're going from a benzene to a benzene with a CH2 and a COOH, okay? So let's go ahead and strategize about that one. And then you have, okay, so you made a carboxylic acid, one carbon removed from the benzene ring. So a good starting step is we don't have to go retro out here. We already know we need to add a couple of carbons out here. So one way to do this is let's go ahead and do the Gattermann Koch formulation, COHCl, AlCl3, CuCl. That gives us C double bond OH. And then we're going to reduce that. Let's use the Clemmensen. Makes toluene. Then we use NBS That's going to put a bromine at the benzylic position. Then we will make that into a Grignard. There you go. And then we can react this. There's two ways we can do this. We can add carbon dioxide, but we haven't studied that reaction yet. So we'll just add formaldehyde to this Grignard and then follow it up with an H3O plus, and that is going to give us the product, which is this molecule up here. Okay. All right. Last one, E. So E out here is you have a benzene, phenyl bromide or a bromobenzene. You're changing it into a carboxylic acid. So we're going to use very similar steps that we used for the previous one. So I think we have like enough room out here to just do this problem directly. So we have bromobenzene. Let's make that into a Grignard reagent. Mg dry ether. And then we will add HCOH, step 1, and step 2 we do H3O plus. And guess what? That gives us exactly this. Actually, it doesn't. My bad. Which in the last one, I got to go fix that. This will actually give us CH2OH. And then to make this into a carboxylic acid, we have to use a strong oxidizing agent like this, and that will make it into carboxylic acid. And that's the same thing we need to do for D, which I apologize I did not do it. So this one would make this, and then to make the product we use a strong oxidizing agent. I think I have too many carbons out here. And that's going to be COOH. There you have it.